Okay, in this problem, we're asked to find the surface area in square feet and the volume in cubic feet of the figure below. So this problem will give us an opportunity to notice the difference between one-dimensional, two-dimensional, and three-dimensional measurements. You'll note on this cube that we're given the dimensions of the width across the front, the length across the back, and the height across here, and those are all in feet. Those are all one-dimensional measurements. The width, the length, and the height are all single dimensions. When we're asked to find the area in square feet, that is a two-dimensional measurement. Square feet, which is often abbreviated like this with a second power, that is surfaces on this. And for example, if we just take a look at one of those faces, notice we can see three faces here. One, the front, the top, and this right side. We see three faces. And one of those faces is 8 feet by 8 feet. And so when we look at the area, we're talking about this region within those one-dimensional line segments that enclose that. So this would be an area. And the area of a square, or in this case a rectangular region, is the length times the width. And in that case, the area of one of those faces is 8 feet times 8 feet. Now again, I'll emphasize that feet is a one-dimensional measurement, is just a length or a distance. When we multiply 8 feet by 8 feet, that becomes 64 square feet, or you could abbreviate it with FT with a exponent of 2, which we still say square feet. But that's 64 square feet, and that is an area measurement, which is two-dimensional. So 8 feet is a one-dimensional measurement. This is one dimension. And this is now two-dimensional. Okay? I'll just spell that all out here. Now that, of course, is only one of the surface faces. And there are 6 of them. 1, 2, the front, the top, and the right side. There's the left side, the back, and the bottom. So there's 6 faces, and all of them, since they're all the same edge measurements, it's 6 of those times 64. So the surface area, and you might notice there is no, here's the surface area of a cube is right here. Surface area of a cube is 6 times s squared. So notice that s is the 8 feet. It's the length of the side. So the surface area is equal to 6 times s squared, and that's 6 times 64. Now, square feet, and of course 6 times 64, that's 360, and 24 is 384. That is square feet, and that is the surface area. SA is our abbreviation for surface area. And again, I'll mention that's two-dimensional. Areas are two-dimensional. And now let's change to 3 dimensions. That's our volume. So volume of a cube, and notice here are our volume measurements. A volume of a cube is s cubed. That is, s cubed in this case is 8 feet times 8 feet times 8 feet. Of course, 8 times 8 times 8 is 512. If you multiply all those 8s, you get 512. But now, since this is no longer two dimensions, remember, is an area. It's area. This is a volume, and this is three-dimensional. Feet times feet times feet is cubic feet, and we abbreviate that like this. So that's the volume. I hope this has helped you understand the difference between one-dimensional measurements, two-dimensional measurements, and three-dimensional